Hello 515 students. Here we're going to talk about the test of related samples, and we're dealing with chapter 11. And this is a terrific test, related samples, and it's often related to repeated measure, meaning I've measured a experimental unit or subject, or in our case a student, 2 times. So if we look at the assignment here, it says, enter the below data into SPSS. Conduct a two-tailed dependent samples t-test to see if the results from test 1 are different from the results of test 2. So I'm asking for the two-tailed test, meaning that they could be greater than or less than in the alternative. Write up your results in APA format. Use a type 1 error rate of 0.05 to evaluate your test. So in this case, for example, we have a student and we have 6 students, but student 1 on the first test got an 81 and on the second test got an 85. So we have 2 observations from the student. And what we broadly call, in this case, our student or our subject, is the experimental unit. It's what we apply the treatment to and obtain the observation from. So in this student's, for example, maybe we had a class and they listened to a class, and then we obtained 2 observations from that student, test 1 and test 2. So the idea of experimental unit and repeated measures or dependent measures on that unit is very important for us in identifying what test to use. This test can take advantage of intercorrelation. When we get the variance from this test, it's the variance of the first group plus the variance of the second group minus twice the covariance of the 2. So if we have correlation amongst the repeated measures here, for example, or the dependent measures on 1 and 2, the variance can be reduced. So this can be a very powerful test for us in finding differences. So it's a desirable test and one we can take advantage of in analysis. So let's go ahead and look at this then. Is to do this assignment, we first need to enter our data. Now we're going to enter student. We're not going to use it in the analysis, but it's good to have it in your data so you know what student you're talking about. So we're going to go up to variable view in our SPSS, and we're going to enter student, test 1. Again, I can't have spaces in my names, and test 2. So I'm just putting that underscore value in there. Now we're ready to enter our data, so we go to data view, click that tab underneath. We just had students 1, 2, 3, 4, 5, and 6. And then for test 1 we had 81, 50, 90, 63, 80, and 40. And then we go to test 2. There we had 85, 80, 70, 98, 90, and 78. Again, if we just took the means of these groups, we would see that one mean is different than the other. But our key question is, do we assume in the population they're different? So we have to get through this idea of chance variation. So we want to say the difference is so large that we don't think it's due to chance. And indeed, if there was no difference, here's the chance that we're wrong, and that's our type 1 error rate. So I'm going to go ahead and run the test now in here. So I'm going to go to Analyze, Compare Means, and Paired Sample Test. This is a paired or the dependent samples test. So what we see then is this looks a little different than our other interfaces. We have variable 1, variable 2, and again, we're not going to use students in here, but it's just so we know which student the data is coming from. Well, to do this one, we need to bump over. What I'm going to do is click on test 1, hold down the shift key, and click on test 2, and then I'm going to bump those over. And they come in as paired, the first paired, test 1 and test 2. And that's all I have to do here. And then I'm going to go ahead and paste that. Now again, because my Sentex window is open already, I don't automatically go to that window. So I have to go down to the tab down below to get to my Sentex window. And there I see my Sentex. So I'm going to go ahead and click and hold my left mouse button, drag across that, go up to the green triangle, which is a run selection, and hit run. Okay, and our analysis comes out. For that, I'm going to go ahead and move these tables. I'm going to go ahead and copy them and move them into my document. Just take one at a time. I want you to include all of them in yours. Okay, now again, this one looks a little long like we did in the last assignment. So I'm going to click on this one. I'm going to go to Edit, Copy Special, and I'm going to unclick the plain text, the rich text, the Excel, and I'm just going to click the image file, and I'm going to say OK. Go over to my Word document, and I'm going to paste that in. And the last thing I'm going to paste in is my syntax, which I have here. Copy that. I'll go ahead and paste that in as well. So now I'm all set to evaluate my test here, so I can write this up. So I see the mean of group test 1 was 67. The mean of test 2 was 83. So obviously in the sample, they are different. The question is the difference big enough to be statistically significant, or that we can conclude, yes, in the population they are. Okay, so we see the correlation. They were not highly correlated here down in the second table. They're only correlated by minus 0.057. Okay, and we're not interested in the correlation test. We're interested in the pair sample test down here. So I'm going to need to write this up in APA. So from the table, what I'm most interested in then is the t-value, its degrees of freedom, and the sig two-tailed value. We see that down at the far right of the table of paired samples test. I'm going to evaluate against this my type 1 error rate here, which I asked you of 0.05. So the sig value, or the p-value, or here that sig two-tailed, is the probability of obtaining this test statistic, which was the t-value of minus 1.765, or one more extreme under the assumption the null is true. In this case, the null true being the sample means are equal in the population. And that gives me my p-value. So the probability of that is 0.138. Now my type 1 error rate is only 0.05. So is this smaller than 0.05? No, it's not. So we failed to reject. This has to be smaller than 0.05. So I'm going to go ahead and write this up then in APA, and it would be a t-test. I get that from my table right in here, and the degrees of freedom are 5. The t-value is equal to, I see it right in my table here, minus 1.765, comma, and then here p is greater than 0.05. So p is greater than 0.05. And that's my APA, because my actual p-value coming from the test, which is the sig two-tailed value, which is equal to my p-value, which is equal to 0.138 in this case. And we know that 0.138 is less than or greater than 0.05. So this test is not statistically significant, and we have no evidence to suggest that test 1 is any different than test 2 from the data we collected. Okay, again, a terrific test, used a lot in education and other related fields, and it's just something we want to know and be very familiar with and know how to do. So go ahead and run the assignment and upload it to Blackboard. Thank you.